In this video, we will use a rainfall stimulator to explore the relationship between organic matter, soil health, and erosion prevention. This demonstration will show how rainfall affects soil in context of different land management approaches that farmers might take. Each container of soil represents a different scenario. Scenario 1 represents unprotected soil. This soil is bare with no cover and very little organic matter. Scenario 2 represents covered soil. This soil has crop residue or mulch laid on top of it. Scenario 3 represents soil with living cover. This soil represents grassland, forest, or a field with a cover crop. It has living plants, roots, and rich organic matter. All three containers have holes in the bottom of the drainage. They lie flat to represent a level field. Equal amount of water will be poured over the top of each container to stimulate the same amount of rainfall. We'll observe three key things. Number 1, the runoff. Water flowing off the surface collected in front of the soil containers. Number 2, the infiltration. Water soaking through the soil collected in the tray below the soil. Number 3, the color. How much soil is carried away by the water? This experiment stimulates a heavy monsoon rain, similar to what occurs during rainy season across much of the tropics. Now we will observe the effects of rainfall stimulation. Let's start with the unprotected soil. This soil has no crop residue, mulch, or organic matter. Here comes our heavy rain. Most of the water is running off the surface, and very little is soaking through the soil. If we look at the tray underneath, almost no water has filtered. Instead, the majority has been collected in the front tray as surface runoff. The runoff water is muddy and full of sediment, showing a loss of valuable topsoil. On flat land, there is already a problem, but on sloped or hillside area, the erosion would be far worse. Over time, the soil in the state will compact, making floods more likely and increasing erosion of fertile land. Next, let's look at covered soil. This soil has a large layer of crop residue or mulch, like rice straw covering the surface. Let's see how this small change impacts water absorption. Immediately, we see an improvement. More water is infiltrating through the soil and less is running off the surface. If you look at the runoff tray, the water is much cleaner compared to the first soil. Very little sediment is being carried away. This demonstrates the power of crop residue. By simply leaving mulch or organic matter on the field, the soil retains more water, erosion is reduced, and nutrients are better retained. Farmers who burn crop residue lose this protection. Burning may seem practical, but it leaves the soil bare and vulnerable to erosion, like we saw in the first example. Finally, let's look at the soil with living cover, representative of grassland, forest, and fields with cover crops. This soil has surface cover but also living organisms and roots holding it together. Let's see what happens during rainfall. In this scenario, we see the best results. Very little water runs off the surface, and the water that does it is clean and clear. Most of the training is absorbed into the soil. The roots and organic matter act like a sponge and holding water in place and preventing erosion. Healthy soils like this are rich in carbon and organic matter, which binds the soil together, improve water retention, and provide homes for beneficial microbes. This demonstration highlights the importance of soil management practices like mulching, cover cropping, and protecting soil organic matter. Thank you for joining us today. If you found this demonstration helpful, please share it with others in your network. Let's work together to build healthier and more resilient soils.